Morning, YouTubers. Got a little different of a video for you guys today. So I thought, since I'm going to be testing all sorts of stuff here and there when I feel like it, that maybe not all of you know how to use a multimeter or a volt-ohm meter, voltage tester, any number of names for these things depending on what they can do. And I thought, why not shoot a video to teach you guys how to use this? So that's what we're going to be doing today. So let's get into it. So the last thing you really want to do is just take your leads, stick them in the wall socket and blow something up, or even worse, shock yourself. So we want to avoid that here. So I'm going to give you a free, imagine that, free education on how to use one of these things. If it helps you out or if you learn something, give me a like or a comment down in the comment box. I'd appreciate it. So let's start out by doing an overview of what we got here. This is an Actron. There's the part number. This is more or less an automotive version of one. I have other ones that we're going to look at too, but this one does a lot of things that are relevant to general electrical testing for like most of you. Like it has tachometer functioning to where it can tell you RPM. It has dwell for setting points on an old distributor. You guys probably don't even know what points are anymore, so that's pretty much irrelevant. It does have amp testing. It tests AC and DC, and then it also is an ohm meter. So what we're going to start out with first is the easiest, and that's we're going to use this for testing voltage. So if you look here, this right here is a symbol for DC straight current, direct current. When you look over here where it has that little squiggly line, that is a symbol, universal symbol for alternating current. This meter can test both AC and DC. So we're going to set it for DC, which it's on. This whole part of the scale is for DC. This can test anything from 200 millivolt for the highest in that setting to appears to be 1000 volt DC. You always want to make sure that whatever you're testing, say if you're testing 500 volts AC, you want to make sure that your meter is rated for it and that you have proper test leads that don't have like cracks in the wire. If you use this meter, which apparently is rated for 1000 DC and 750 AC, and you hook this to 1500, you're likely to shock yourself right through these cables because they will become conductive and they won't be able to hold the voltage back. So if you look here, this one gives us an indication. So for category 1 up to 1000 volts here, and then also it does category 2, which again are both here. This is COM, which means common. We're going to put our black cable there. And then this is for voltage testing. When you come over here, you see how these hookups say 200 milliamps max fused. And then this one says 10 amps fused. So in order to do load checks to see how much current something is drawing, you have to move this to here for anything up to 200 milliamps, this over here for up to 10 amps. But we're testing voltage, so we're good right there. Let's power it up. So this meter even tells you you need to hook up both to there, which we are. So we're good. And it's reading 0 volts. So this is also likely a self-zeroing meter. Some meters, especially cheaper ones, might read like 0.4 or 0.2, and that's just because they don't auto zero to nothing when there's no power hooked up. So we'll start out first by taking this AA battery, and like I said, we're in DC, which I didn't even readjust. We're going to be testing this, which if you look here, might be, it says 1.5 volt. Let's see if I can get that to focus. There it is, 1.5 volt. So by setting this meter to 2, it's going to give us the highest resolution, and I'll show you that. So this is labeled Positive is the little nipple thing, if I'm allowed to say that on YouTube. So if you read down here, we have 1.549. So this battery is rated at 1.5 volt. It's a little bit over that. That's pretty typical. This thing should be pretty close to fully charged. Therefore, its voltage will be higher. Now, when you drop below 1.5 volts, that's going to indicate a state of discharge. Now, I'm not sure what this battery will read fully discharged, because it will never read, say, 0. Even with a full discharge where it won't run what you hooked it up to, it still will read some voltage, generally speaking. Now, I'm going to move this up to 200 volts, and we're going to check the same thing again, and you're going to see on the meter it just reads 1.5. What it ends up doing is moving the decimal point over, and then it cuts off. So this, on this scale, yeah, it's a 1.5 volts, but on the 2 volt, we have more information. So rather than just 1.5, it's 1.548. That's extremely important if you're testing sensitive electronics that operate in a very narrow window. And yeah, you can see it's going to self-clear itself. Yeah, see, it's going to zero itself out. If you're testing sensitive electronics, you want to be in a scale that it works. Like on the 200 millivolt, if your electronic that you're testing is 100 millivolts, well, if you read it on too high of a scale, you might think it's okay, and it might not be. So be aware of scales. Now, this is the positive, this is the negative on this battery. So the negative is the wider terminal. We're going to hook this up in the wrong scale and look at it. You see how the meter just reads 1? That's telling you that it's out of range. So we're going to move it back over to 20. And I'm going to connect it up again. And we got 9.41 volts. So this is a 9 volt battery. Again, very typical that fully charged battery is going to read over the rated voltage. And since this is direct current, it's a steady voltage at 9 volt. And well, it's a battery too. Batteries can't have alternating current, but so we're at 9 volt. Now I'm going to go up to 1,000 volts. And again, you can see 009. Well, it's 9 volts, but we lost all the resolution there. So pretty simple stuff. All right, let's talk about ohm testing. So this meter I have set for 200 ohms. It goes from 200 all the way up to 20 million. Now for ohm testing, if you're looking for a short, it's a great way to test for it. The first thing you want to do when you have your leads hooked up, which this one's showing you hook it up just like for voltage testing, you want to touch them together and make sure that the reading is low. So right now it's 0.2, probably 0.1. Yeah, it goes down to 0.1. That means we have continuity or very low resistance between these two wires in the meter. If at 200 ohms or whatever your meter reads, and it might read 2 ohms, if you have a very high resistance reading on that, that could indicate that your wire is broke or your tip is broke. And it's more common than you would think. If you look here, these things are bent up pretty bad. What's saying that it's not broke inside of there? So by checking for that and seeing that you have a very low resistance value, that's good. That means that the wires are intact. Now let's start by testing something very simple. This is a very thick steel table. Our resistance from the positive to the negative should be very low, and it is. It's pretty much the same as just touching the tips together. And I'll go all the way from opposing sides of the table. Again, very low resistance, which is what is to be expected on something. It's forming a path right through there of very low resistance. I'm going to check the ground cable on my welder, or from my welder. And this also should have very low resistance. And it does, very much the same as just touching the tips together. When you're checking wires, like especially ground wires, say in a car, or where you have an intermittent power problem, by checking and ohm metering out that circuit or that wire, if you see high resistance, like it can't pass electricity, that's a very good indication that you have a problem. Now, wires on the small scale, like this very thick, probably 6 gauge, nah, it's bigger than that, probably 2 gauge wire, on this scale should have pretty much no resistance. If you see even a smaller wire, like say a 12 or a 14 gauge wire that's only 10 foot long, and you test it and you're getting like 10 ohms or 20 ohms, you probably have an issue with maybe corrosion, or the wires broke, something, because your resistance on copper wire at low distances should not be very high. It should be very close to what it is just directly touching it, the two tips to one another. Now, this meter will check up to 20 mega ohms or million ohms. Everything above 200 is primarily for testing certain pieces of electronics. So like if you had a resistor of a specific known value, like 20,000 ohms, you could actually check that and verify that it's within spec. So very common with electrical troubleshooting that you would be up at 20,000 ohms verifying components. Now, on the small scale, like I said, for just checking wires and stuff, you want to be up in near the 200 or lower. This meter also has what's called a continuity check, which is depicted right here, and it has an audible sound. So let's switch it to that. Not all meters have it, a lot of them do. This has also got a diode check mode. So a diode is a one-way valve for electricity, and this would allow you to simply check if electricity will go one way and not the other and verify it's working, because if you have electricity that goes both ways, then the diode's bad. So this functions as both a diode and a continuity check. So continuity just means that some form of current can pass through it, which means like this piece here, this tip is actually attached here. It doesn't give a resistance value generally, but it at least alerts you that they're connected. And I'll give you an example. And actually this does show resistance. And just like if I push this on the table, this should give, yep, and it's still very low resistance. I'll check over here. Resistance might be a little higher, not really. Let's do a little fun experiment. I don't know if this is going to work. I'm going to try and go through this paper and see if, yeah, it doesn't seem to want to. Thought we might be able to get a resistance reading. Oh. Yeah, it doesn't really want to. I want to simulate a little bit of a resistance, but it doesn't seem to want to, which is fine. But you get the idea on that. The continuity, the audible alarm is invaluable for tracing ground wires and verifying what's actually hooked up to ground and what's not. Now, the whole RPM, we're not going to deal with that. The dwell, we're not going to deal with that. That's all car-specific stuff, and I honestly don't have anything that has a coil that I think would be functional for this, or we don't adjust points anymore. I mean, that's old school. That's like back with your 750 Holley double pumper and your terrible factory GM distributor. Not good. Now on amperage, this depicts amperage testing for DC, not AC. So be mindful of that. See that little indicator there? That is the same that's depicted here. You do not want to check for AC amperage with this, okay? Either it won't work or you may end up blowing the fuse. So let's talk a little bit about the amperage setting. This has both up to 200 milliohms, or not milliohms, milliamps, Jesus, and then 10 amps. If you're checking fuses in a fuse box on a car, you would probably want to have it on the 10 amp setting if the fuse is rated under 10 amps. You don't want to hook this up, say you pull a fuse out and then you go between both sides of the fuse without a fuse to check how much current a circuit is drawing. If you have it on a 30 amp fuse and you pull the fuse and use this instead, you'll probably pop the fuse internally. You also, if you just went and tried to check the battery, like a 12 volt battery, and touched both the terminals, you're going to instantly blow the fuse in here. So the fuse is there to prevent you from getting shocked or from having these wires melt. I mean, these things have such a small little wire in it. It's really only rated for about 10 amps. Any more than that, you'll blow the wire. So the fuse is there to protect you if you make a mistake. But it's primarily used for, on DC, as troubleshooting. Like I said, you can verify how much electricity a certain circuit is taken. So if you have like a radio circuit that keeps popping the fuse and you check it and it's pulling 7 amps and it's only got a 5 amp fuse, well, you probably have a short. So that'll tell you. Now, to check with this, to check amperage, you would leave the common, which says, where is it? Common up here, it says common. And then this is for milliamps, and then this is for amps. And by amps, up to 10. So you would change it here, and now you're not going to get any reading here because we're not actually pulling any current. So this is to measure direct current up to 10 amps. So let's talk about AC current, because this device will also do that. So we're going to put it back in here, and not AC current, but AC voltage. And I'm going to go get set up on an outlet so we can talk about that. All right, we are about set up here. So our meter, we are going to relocate down to, if you look here, the voltage alternating current. Now, a standard wall outlet is under 200 volts. It's going to be between 107 and 120. So we left it on that. Now, we're going to start off, let's see if I can't put this up here where you can read it. Perfect. Hopefully you can read that. We're going to start off by putting the negative into the ground, which is going to be the center pin here. And then we're going to put the red, which is the positive, in the smaller of the two spade connectors. Oh, and of course this is tamper resistant to prevent this. All right. So if you look there, my voltage here, being that it's at night and the power company is probably producing a fairly high voltage and nobody's using any, my voltage is at 119.4 volts, which is higher than it normally is. During the day, it's about 115, 114. So that's reading from the positive to the ground. So I know that the ground is actually hooked up on my electrical service, otherwise I wouldn't have a reading. Now let's go from the positive to the neutral. So we can see there that it's still around 119 volts. Now, I know that this outlet is wired correctly because the hot wire on an outlet is a smaller terminal. The wider one is going to be your neutral. So this is wired correctly. This is a great way if you want to check if an outlet is wired correctly, because between the ground and your hot should be 119, and then between, I'm going to have to pop this over here. Come on, there you go. Between the neutral and the ground, you should have nothing, which we don't have anything depicted here, which is good. If we had power on the neutral wire, we would have a potential issue with how the circuit's wired or what's hooked to it. Could be a short, any number of reasons. Again, this is just simplistic testing. You want to make sure also, when you're putting this into your outlet, these are tamper resistant, where you actually have to have something going in both in order to push anything in. Don't grab these things by the tip like this and try and shove it in there. You're going to shock yourself, and that's no fun, so don't do that. Be smart. Also, you want to tend to grab it here, not down on this wire. It's very easy for this to get nicked, and who knows, you could get shocked through it. So just like this, again, I'll show you one more time. There we go. Again, 119 volts, give or take. That's what a normal outlet runs off of. So now let's look over at a 220 circuit. All right, here's one of my welding receptacles. So this is a 220 circuit or 240 volt circuit. This has two hots. So even though one pin is smaller than the other, these both are actually powered. That's how you get your 220 to 240 volts. The top pin here is actually the ground. Now, if you're testing a dryer outlet, you'll actually have 4 pins. You'll have a ground, one hot, second hot, and then you'll have a neutral as well. Because this only needs a power 220 volt appliances, well, my welder, you don't need a neutral wire. The wire itself is a neutral of sorts, I guess. So what we're gonna do, we're gonna take the meter, and you should be able to see this. We were on 200 volts. The problem is that this is going to be over 200 volts. So I put it on the 750 volt scale, and we're going to carefully insert those in there and see if we can't get, there we go. So we're at 239 volts. 240, which makes sense because whatever your wall outlet power is, if you double it, that should be in the ballpark of what your 220 volt circuit should be. So during the day, I'm actually only about 230 volts on this. Now, if you want to check an individual circuit on this, you can go from the ground and one side, and we should get a reduction in voltage. A little difficult, and we have 120 just like we do at a normal outlet, and then the same thing here. This side should also be, and it is 120. Apologize for the darkness back here. We're kind of in the hole of my shop. So let's go on to some more testing. All right, so my welder right now is set for DC output for stick welding. We're gonna put the meter back in DC mode, and we're checking voltage, not amperage. So we're gonna put it on 200. Now this has a built-in voltage tester. It's telling us that our output is 78 volts right now. So what we're gonna do is we're gonna go from the positive, I'll set this where you can see it, to the negative. And this is reading 79.3, 79.4. So the meter on the machine's close, not quite. This is reading a little bit higher. Which one's more accurate? Who knows? But we're at about 78, 79 volts. So either way, pretty accurate. Now, I'm going to change this to AC. I'm not sure if the output is going to be on AC or not. Let's see what happens. It will weld on AC. Okay, so, but without a circuit established where you're welding. Yeah, so this is still reading DC. Let me switch it to AC and see if we get a reading. Because it's entirely possible that until it has a welding circuit established, aka you're burning a rod, that there will be no output on AC. Yep, and that appears to be the case. So once you strike an arc, it probably starts the arc on DC, and as soon as the arc is struck, it switches over to AC. So not too surprising there. So let's switch over, and I'll just leave it run. Let's check this little guy over here. Let's turn this on. Let's check what the open circuit. Now what we're testing here is open circuit voltage. So when there's no welding current, see, that's pretty interesting. I left it on AC. It's reading output of AC current. Very interesting. And this is a DC current welder, so let's go back over to 200. So it says outputting 81 volts. So that's pretty interesting. The output on this on DC is apparently so dirty that it's actually outputting AC current. Not too surprising. So open circuit voltage between these are pretty similar. Interesting test. All right, let's go and check some other stuff. All right, this should give us the same results. So we checked directly on the welder. We were checking DC output. I just clamped that into there. Now this whole table is grounded. Now you don't want to do this with with your hand on the table. In the event that something's shorted here, you'll shock yourself. So what I find interesting, so we're going from essentially this stinger all the way through the meter into the table, and then it's returning back to the ground on the machine. What I find interesting is that this is reading exactly what the machine is reading over there. It says 79.9 on the welder, so the open circuit voltage is reading exactly the same as the machine, but when we checked it directly, it was not reading the same, so I must not have had a good enough contact, but we were exactly at 80 volts. So that's interesting. Now this thing is isolated with plastic to where it doesn't make contact with the table when you touch it, but if there was a piece of this broke off, it would spark and weld itself to the table. All right, I think you guys got a pretty good idea about how to use this meter. Very simplistic, like I'm not going into advanced electrical troubleshooting here, but just to give you an idea of simple functions. Now let's look at another meter that's a little bit different and has different options, just to familiarize yourself with something new. All right, I have another meter here that we're going to go through. Let's turn it on. So this meter is obviously a little bit different. It has this clamp up here, that's different, and it has a different switch here, a little bit different looking. The leads hook up on the bottom. So let's first talk about what this clamp is. This is designed to where if you pass a wire through it, like this welding cable, and you clip it, it reads the electromagnetic energy on that's following the wire, and it can tell you how much current is passing through the wire. So very handy, like if you want to check your welder's output, or if you want to check the current draw on a circuit, you can put it through here, and it's fairly sensitive, so it'll read, you know, I don't know that it'll read a 1/4 amp, maybe it will, but it'll definitely read 15, 20, 10 amps, somewhere in the neighborhood of that. And this does both AC and DC. So let's look at the first function here. In this mode, it reads up to 600 amps, and it reads AC or DC. Now right now, it's checking direct current. In order to switch it to check AC with the clamp, we have to hit the function button. Now that's swapped over to AC. So that allows us to check, say, a motor, electric motor in an industrial plant, or even the current draw on the welder that I have. The next is just 60. It gives you a better resolution. If you check, 5 or 10 amps, this will give you a more accurate output. Again, it's on DC. We have to function it over to AC to check AC. Now voltage, this does again, both AC and DC. We're on DC. To check AC, we got to flip it. This also has a frequency check. Frequency, and I believe that's low pass filter. By putting it in this mode, you can check frequency when you pass through this. Now, since it's on voltage and it's on DC, let's test. And I'll bring this up over here. Let me zoom out a little bit for you. All right, I'm going to poke the stinger here and get this pen out of my hand. And then the table. So we're at 79.8 volts. Let me slide that up for you. And this auto zeros, so it's going to meander around. This isn't the most accurate meter, and as you can see, it's kind of flip-flopping around. But we are at 80 volts open circuit, which is exactly what the welder says that we're at right now. And that's DC. Now, if I select AC on this meter, we should have 0. And we have nothing. Which the interesting thing is that other cheaper welder actually indicated AC output. So I think its output's pretty far from clean. All right, so it has a frequency test where if you hook this up to something and there's a frequency that's being outputted, it'll tell you what that is, because all the frequency is, like in the case of an AC waveform, it's just positive and negative voltages. So that'll read frequencies. Now this is a continuity, so an audible ohm test, so audible continuity, and it's also a diode check. So let's go through functioning on this. This is continuity. This should beep when I touch it to the table. And that's telling us that we have a connection between these two leads, which we do. You saw it. Now, speaking of the leads on this, my other tester did not have them. This meter is rated for up to 600 volts. This actually has these little caps to protect it. If you're grabbing right here and you hook this to 600 volts, you could get, in theory, an arc gap from right here onto your thumb, and that would not be a good day. So this uses isolators that go on here to keep your fingers nowhere near that level of voltage. So if you're actually going to be testing 600 volts, which I would honestly, unless you know what you're doing, and this is not really the video to be prepping you to check industrial power, but you want to make sure at higher voltages your caps are on here. Which I kind of said earlier about safety a little bit, but really, if you don't know what voltages you're playing with, or you're trying to do some kind of microwave transformer device to save the world, whatever you're working on, you don't want to be an idiot with electricity. Probably the most common thing I've heard, and it even happened in my city, elderly couple took a couple microwave transformers up the voltage from the wall to, I don't know, 5,000 volts, and they were hooking it up to slabs of wood to get the lightning effect in the wood. Well, guess what? They were outputting multiple thousands of volts. Not even these are rated for 1,000 volts. And what ended up happening was the wife, I guess, got electrocuted because she got too close to the wires. And then the husband went to try and save her, and he got electrocuted, and both of them ended up dying in the garage or something. So high voltage is nothing to screw with. You want to use proper PPE, and if you don't know what the proper PPE is, you're probably not qualified to work on it. So, all right, enough about being the safety guy here. This also has Celsius and Fahrenheit check. There's a little probe in the package for checking thermometer for temperature. Beyond that, the rest of it you really, I guess, don't really have to worry too much about. Now, this, like I said, the connectors plug in the bottom, a little different than the other meter. There's a couple things that I just want to tell you about, and then we can wrap this lesson up, since I'm sure you've already learned enough. When you're checking AC power, okay, let's draw a line. I'm drawing this through my camera, so not bad considering I'm not actually looking at it. An AC waveform, like when we check the wall outlet, is both positive and negative. It's in a sine wave because that's what the generator at the power plant that powers your home or your shop produces. When you're checking AC voltage, you're actually reading what's known as an RMS value, a root mean square. That is the average voltage. So like we saw 120 volts, that's the average, okay? The actual voltage at that outlet is higher than 120 like we saw earlier. It might be 140 or 50 volts. That is the peak. That's this point of the waveform, okay? Peak power. Now, with 220, it's going to be, again, the same deal. Is these meters read RMS, not peak. If you want to know what the peak voltage is, so what's only for a small part of the wave, not the average of the wave, you need to get a meter that can read that, or an oscilloscope, or any number of electronic devices that will tell you that. Because like I said, this is not peak power, this is just or peak voltage, it's the average voltage. So that's worth noting too. And if you're just testing stuff, honestly, that's not really a big deal if you didn't understand that, and you could probably forget it. But if you're designing electronic circuits and stuff, if you design it to handle the average and not the peak, you could run into serious issues with that. Beyond that, not sure what this is. This might be NC, maybe non-contact voltage tester. Could be where, and I doubt it would do it on DC. Let me see here. Huh. Yeah, I'm not really sure what that is. Since it doesn't pick up DC, maybe it's a non-contact for AC, that could be, but not a big deal. So anyways, I think I covered enough to get your feet wet. The biggest thing is, like I said, if you're testing voltage over about 240 volts, like don't be an idiot with it. It doesn't matter even if the current level's low, like high voltage will make an arc gap like no problem and shock you. So be careful with that. And make sure that you kind of have an idea, like it doesn't hurt to read the manual of your meter, get familiar with it, and work with your little batteries and stuff for a while until you get comfortable, and make sure you hold your probes correctly when you go checking outlets and stuff. And be careful, don't be an idiot. You know, this, I'm not gonna put a disclaimer on this video written by a lawyer, so, you know, be smart about stuff, use proper equipment, and if you have any doubts, then don't do it at all. Hopefully this helped and you can start on your journey of testing stuff and getting a better idea on how the world around you works. I will be picking up a old Lincoln Tombstone welder, and in a safe manner we're going to disassemble it and actually test every aspect of it to demonstrate how it works. That'll be down the road, but it's something to look forward to. Until then, if you got any questions, comments, concerns, you know where to leave them, or send me an email. Thanks.